What's up, everybody? In this video, I'm going to be covering USACO's 2020 Open Contest Bronze Level. Problem number 1, Social Distancing 1. A terrible new disease, COVID-19, has begun to spread among cows worldwide. Farmer John is trying to take as many precautions as possible to protect his herd from infection. Farmer John's barn is a long, narrow building containing N stalls in a row, where N is between 2 and 10 to the 5th. So stall 1, stall 2, stall 3, just lined up. Some of these stalls are currently occupied by cows and some are vacant. Okay, so maybe this one has a cow, maybe 3 has a cow, but maybe 2 doesn't. Having read about the importance of social distancing, Farmer John wants to maximize D, where D is the distance between the closest 2 occupied stalls. For example, if stalls 3 and 8 are the closest that are occupied, then D is 5. So that's just 8 minus 3 equals 5. So in my example above, if I have a cow in stall 1 and a cow in stall 3, then my total distance here would be 2. It's not including both barns, but it's not just counting the empty space. It's the actual physical distance, which is 2 stalls over. 2 new cows, 2 of them, recently joined Farmer John's herd, and he needs to decide which formerly unoccupied stalls they should be assigned. Please determine how he can place his 2 new cows so that the resulting value of D is still as large as possible. Remember, D is the closest 2 cows. Farmer John cannot move any of his existing cows. He only wants to assign stalls to the new cows. Okay. Input format is a file called soakdist1.in. The first line of input contains N, and is how many cows or how many stalls there are. The next line contains a string of length N of zeros and ones, that's this down here, describing the sequence of stalls in the barn. 0 indicates that they are empty stalls, and 1s indicate occupied stalls. The string has at least 2 zeros, so there is at least enough room for 2 new cows. And you could put all the cows directly side by side. That's the solution, and then the distance would be 1. And we're guaranteed at least 2 zeros, which means we're not going to have a situation where we can't place the cows. Everything is going to have a distance with a minimum being 1. Our output is to print the largest value of D, the closest distance between 2 occupied stalls that Farmer John can achieve after adding his 2 new cows in an optimal fashion. So for example, in this example here, I've got, let's do, I'm going to number them starting from 1. They didn't specifically number the stalls, so I'm gonna use 0 indexing instead of starting at 1. 1, 2, 3, 4, 5, 6, 7. That way it approximates kind of how your array would be. 9, 10, 11, 12, 13, and 14. Okay, so I have a cow install 0, 1, 2, 3, cow install 4, 1, 2, cow install 7 here, 1, 2, 3, 4, cow install 12. Is that? Hold up. 1, 2, 3, 4, 1, 2, 3, 4, and 12. I don't have the right number here. Oh, because there's no 14, because there's 14 of them, so 13 would be the highest index. Psyched myself out. I was going to start with 1, and then I changed it. Okay. Okay. So in this specific setup, our 2 closest stalls appear to be 4 and 7. 4 and 7 would be a distance of 3, whereas 4 and 0 here have a distance of 4, and then 12 and 7 have a distance of 5. But our output for if we had already placed the cows and this was our output, our closest distance here would be the 4 to the 7. So what we're going to need to do is we're going to need to place 2 cows. We could put the first cow right here on the 10. We could put the second cow right here on the 2. Oh, and it says here, in this example, Farmer John could add cows, making obviously look like 10x, 10x, 0, 1. Okay, so they marked X where the X's are the newly added cows. Let me write that out here. I'm going to write the 1s and 0s. So the original output string, or the original input string was 1, 0, 0, 0, 1, 0, 0, 1, and then 1, 2, 3, 4, and then 1, 0. So they put X's on 2, and looks like 9. So now our cows are here to here. That's an interval. Here to here is an interval. Here to here is an interval. Here to here. Here to here. The smallest interval appears to be a distance of 2. From 0 to 2 is 2. From 2 to 4 is 2. From 4 to 7 would be 3. 7 to 9 is 2. 9 to 12 is 3. And then there's nothing to the right of 12. So even though I have 2s and 3s, the smallest gap would be 2. So I would recommend doing a couple of these with paper and pencil, like usual. Try a couple different strings and try a couple different scenarios. See if you can think about what the edge cases are going to be and what's going to throw you for a loop. Then once you're done with that, I recommend pausing and running through a couple of these and then come back and we'll walk through the solution. Clean this up. Okay, so with this example here, the solution to this example is fairly straightforward. And there's two ways to solve this programming problem. I'm going to explain both of them. There probably are more ways, but there's two primary ways that this could be done. Generally speaking, what you're looking for is you're looking for the largest gaps and you're trying to fill them. So for example, this is the largest gap. If I were to fill that, now it becomes two small gaps. This is the largest gap over here, and I could split it either here or here, either place. And then that would be the best possible solution. The thing that's going to cause issues is when you have open spaces on the edge. So for example, if I have two potential curveballs. One is going to be if you have open spaces on the edge. So let's look at how that would work. 0, 0, 1, 0, 0, 0, 1, 0, 0. Let's do this. 0, 0, 0. Okay, so in this particular case, if I were to walk through and try to find the largest internal gap, I would find a gap right here. And then usually when you find your largest gap, you would want to put a cow in the middle if you're trying to place one cow. That one cow would go in the middle, and then that would make my largest distance here too. But even if I have open spaces here, let me see if I'm going to adjust this a little bit. Make that 2. Let's make this 2. In this particular case, let me see. Let's do one more over here because that's still going to be 2 anyway. Because it doesn't matter. If I have this right here, well, let's do it like this over here. Okay, so if I have this right here, if this is my largest gap, which it is, and I've got 3 zeros, when I place a cow here, I'm going to have a distance of 2 here and 2 here. But it's important to point out that with this gap right here, I wouldn't want to put something in the middle of this gap. Specifically, what I would want to do is put something on the end. If I put something on the end, then I don't have to worry about any cows being to the left of it. So even though my gap from here with 3 will go down to a gap of 2, here the gap's only 2 and it goes down to 2. If I had a middle gap of 2, let me erase these guys right here, I'll do 2 zeros here. If I have a middle gap of 2 like this, despite the fact that it looks like it's the same number of zeros, because here I have 2 zeros, here I have 2 zeros, and here I have 2 zeros. In fact, putting one in the middle of this gap would give me a distance of 1, whereas putting them on either end would give me a distance of 2 on the end and 2 on the end here, and then I would still have my gap of 3 in the middle. So that's the first thing to watch out for, is being able to place cows on the corners, even if it's a shorter sequence or an equal sequence. Putting it on the corner gives you the most room because you don't divide it in half. You don't have a cow on either side like you do with an inside gap. The second thing to watch out for is if I have something like 1, 0, 0, let's see, 0, 0, 0, 1. Okay, so my largest gap, I only have one gap. Let me go ahead and put zeros on the outsides just for giggles. Okay, I have my largest internal gap here. This is the largest gap, but I don't want to put my first cow in the very middle of this, because then my next cow is going to have to either go like here or here or here or here. And in each of those cases, if I were to put a cow in one of those locations, I'm making a distance of 1. In this specific situation, when I have a large gap like this and it's just one large gap, the thing to do is actually to place them at 1/3 the distance, which would be here, and then 2/3 the distance, which would be here. So as far as how to actually get this put together in a solution, you've got kind of 2 approaches. In the first approach thinks of all the possible places you could put the cows, every possible combination. So the first way, for example, is you could put it on the left end, and then right end. Or you could put one on the left end and then a middle. You could put one in the middle and one on the right end. You could put them both in the middle of whatever the largest gap is, middle. Or you can put them in thirds on largest. So these are your scenarios. Now, you can also do this. There's a second way to do this, where basically you place one in largest gap, place another in largest gap, and then remove both, and then place both in largest gap. Okay, so these seem very similar, but the thought of how you're going to approach it is a little bit different. In the first method, if we have some sort of a sequence of cows, then either we're going to be placing them on both ends, one end here and one end here, or we're going to be placing one of them on one end and one of them in a middle gap somewhere, or we're going to be placing both of them in a middle gap, but different middle gaps. Maybe one goes here, let me 1 0 0. Let's do another 0 in here. Maybe one goes in here and then one goes over here. Or we'll have 1/3 of the way through whatever our largest gap is, and then have them both in the same gap with 1/3 of the distance. So in that case, with this would be our largest gap here. We could put like one here and one here. And what you would do is you would try each of those 5 combinations, doing the ends, doing one end and a middle, doing a middle and a right end, doing both in the middle, and doing thirds on the largest. For each one of those, you would run through and calculate if you were to put them in this particular position, then what would be your smallest gap? If you were to put them in this position, what would be your smallest gap, and so forth. The other way to do it is to do more of a simulation. In the simulation, we want to place one in the largest gap, but we have to watch for the ends. For the middle gap, if you have a distance of, say, for example, what is this? 1, 2, 3, 4, 5. If you had a middle gap of 5, then your new gap size would be 5/2. If you have an end of 2, your new gap would be 2 minus 1. So when you're placing on the end, however many zeros there are, your distance is going to be 1 less than the number of zeros. When placing in a middle, your new distance for that gap is going to be half of however the distance is. So what you can do is run through and find where's the best place to place one cow, whether it's on an end or whether it's in a middle, and you actually place the cow. Then place a second one, again repeating and going through from left to right, finding what the largest gap would be. Remove both of those cows, and then run one more time after having removed both, find your single largest gap, and place them at 1/3 and 2/3 of the distance. Now, this is basically the same thing, except with the second version, you're actually running a simulation of placing the cows and then measuring. With the first version, you've got 5 different scenarios that you're calculating based on the scenario. Either one is fine. I coded it the second way, and it was pretty straightforward. The first way also is pretty straightforward as well, but the first way is a little bit more of a calculation type approach. As far as storing your data, my recommendation is to, depending on your language, get some sort of a sequence that you can mutate. So in C++, you could just do that with a string, since you can do like cows, square bracket 2 or whatever equals the character 1. That's totally fine. If you're doing Java, we can't do that with a string. I believe Python also doesn't allow string assignment. So for Python and Java, you probably want to switch to some sort of a list. You can do that quite easily. In Python, you would just do list of cows, whatever it is you read from the file. In Java, you probably would want to make an array, and then just maybe like a character array, and just fill it in as you read through the string. Once you read the string in, you can get the size, set the character array based on that, and then just copy into the character array. Once you get your array of characters and or your string, if it's C++, you'll have a sequence where it's like 0, 0, 1, 0, and so forth. When you're doing your calculation, if you want to place the cows, then what I would recommend is do the same thing that they did in the instructions. Change it to the character X, and count everything that's not a 0 as a cow. So you get your first cow placed, you get your second cow placed, again, changing it to an X. Once you do that, you place your 2 cows, you can run through and measure your smallest distance by just checking all the distances. Once you've done that, you run by, and everything that is an X gets changed back to a 0. Then you do your second pass, depending on, again, which method you're going to use, where you find the single largest gap. Let's make that a 1, and you try to place them at 1/3 and 2/3. The way you'll want to do that is figure out your gap size. For example, if I was going to place it here, let me actually 0, 0, 1, 0, 0, 0, 0, 1, 2, 0, 1, 0, 0. Okay, so when placing in thirds, then what you want to do is you want to get the starting index as well as the gap size. Add 1/3 of the gap size to the starting index, I plus 1/3 distance, and then I plus 2/3 distance, and that will place them here and here. And then from there, again, run through and you measure whatever your smallest distance is. If you're going to go with the first method that involves testing everything, again, you would just try each combination. You'll need some way to find the single largest internal gap and place a cow. Actually place the cow, and then once you've got that, then try putting one on this side, see what your distance is, remove it, try putting one on this side, see what your minimum distance is, remove it, and then since you know where your largest gap is, try it on thirds, and then remove it. And then, and then also another one will have to do a pass where you try and find the largest internal gap and put one there. if you're doing the five different scenarios method. If you're doing the one where you run the simulation, then it's just a matter of 1, 0, 0, 0, 0, 1, 0, 0. Oops, I need one more 0 in there. First, you find your largest gap, which in this case is here. Put a cow in the dead center. Find your next largest gap. In that case, actually, one of the ends would be more appropriate because that would leave your largest gap. Place it there. You place your 2 cows. You run through. You measure the distance. Remove the x's, and then next pass you run through. Find your single largest gap. Whatever I is, again, it's I plus 1/3 distance, and then I plus 2/3 distance. And then once again, once you get those cows placed, run through and measure your distance. There's no real complexity issues, time complexity issues. So whichever approach you use, you shouldn't have to worry about timing out. And you can make as many passes through this as you need. So if you need to make 5 passes or 10 passes through the string, it'll be totally fine. As long as I can't even think of an n-squared scenario or an n-squared solution. So pretty much any solution you come up with will probably work, provided that you're getting the cows placed on. Just remember, watch out for the corners, because again, that doesn't divide the distance in half. So those count. This two cows here counts for more than 3 cows in the middle. Actually, they're even. 2 cows on the edge is worth 3 cows in the middle. And then also watch out for placing in thirds of a distance, because there may be scenarios where you have a large gap and you'll have to place a third, 1/3 and 2/3 of the way through. Alrighty, so that's the algorithm. Good luck coding it. I'll talk to you in the next video.